friends, neighbors, and of course, the YouTube comment section. Hello and welcome back. So today, we are going to build the LM Tour Systems stalwart, the 25-foot power cable. This is something that we include with most of our systems. If you've got a little power inlet box or anything like that, you get a heavy-duty SJEW power cable. The SJ Service Junior power cable. This is our standard one. We build, I think last year we maybe built a few miles of these. We build them in bulk. And generally, when we have stuff that comes through, Ben or I will just build these. And generally, I keep 5 or 6 that are usually just made, like if we have some downtime, if we've cleaned the shop or done something, we'll just make these in bulk. But we just received a fairly large order of them, so much so that Ben and I can't build these things in our free time, and I have to bring a shop guy up to just knock these out while Ben and I are working on something else. So to that end, I came up with a 25-step build procedure for this, and I need to double check my math to make sure that it clearly and concisely states everything, so that the builder of said cables has a video to reference in addition to my cleverly placed adjectives. And I thought to myself, you know, why don't I just give the comment section something to comment about? So you guys get ready. We're going to build a power cable. Let's see how many NEC violations I can have with this. Drinking game. Billy NEC violation. So to start, we will take our pre-built cable and set that aside and grab our pre-measured 25-foot SJEEW cable. I didn't think that you guys would need to see me measure this. I think you've got a good idea. So step 1 says we need to measure 2 pieces of clear heat shrink. One is 4.5 inches, and the other is 2 inches. The 4.5 inch one is so that you can put your own label on the cable, and the 2 inch one is designed for our LM Tour Systems logo. I forgot the connectors. Hang on. As I say with most things, if you want the procedure or the build to take 3 times as long, do it on film. So I like Lex brand connectors, specifically the LexLock X515 series. And I like them because they're A, cool looking, and B, they're very easy to build. So what we do here is we take them apart and we take this strain relief portion off of the back, and then I will use my Klein flush cutters to pry the cable reducer out. So this is a 12 gauge cable. You don't need the reduction, but say you're building a 12 or a 14 or something else, you need the reduction in there. So the way we do this is I build the female end first. So heat shrink, LM Tour Systems logo, because like with most things, if it can say LM on it, it should say LM on it. And then the back portion of the cable. And that is steps, let's see, 1 through 5. Oh, it printed this double-sided. How eco-friendly. Oh, this is steps 1 through 7. So step 8 says, take cable and measure 2 inches and put a bend in it. Well, I've built about 1,000 of these cables, so I know what 2 inches looks like. But for the untrained, I need to assign a mathematic number to it for the sake of product consistency. We will take our blue side cutters and trim the insulation out. So in case you're wondering, the S, so things that are referred to, say, as SO cable, this is SJEW cable. This acronym right here, S is usually submersible, or it can also be severe. J is junior. So this is severe junior cable, which means it basically just dictates where you can use the cable. I'm going to link you the Wikipedia page underneath here that tells you what those acronyms mean. I'm doing this off of the top of my head, but some things are like O for oil, W is water resistant, S I think is submersible sometimes. But basically, it just dictates. So when you're in the junior service, if you notice that the cable separators that I pulled out of here were like a mesh, when you get into the severe service stuff, they're actually paper, and this jacketing is a little bit thicker. But for 99% of the things that we use this cable for, mostly just as a power input cable, you're not going to have people walking on it unexposed. I actually got very nerdy previously and read the cable specifications. So when you start to get into the severe service cable, it's primarily designed for portable applications like carnivals, as an example. So if you've been to like a state fair kind of thing and they have cables that are just on the ground without a cable tray, that's a severe service cable, so you can walk directly on them and you don't have to tape them down and do that kind of thing. Should you tape them down? Yes. How do you tape it to grass? I'm sure the comment section will tell me how wrong I am about all of that, but again, that's what it is. So the way that we strip that is I use, we found that 2 inches is good. Again, I've mentioned this on previous videos. Once you sort of figure out how long your hands are, you can use it as a measurement. So for example, from this portion of my hand to the tip of my hand is 7 inches. So I will use that oftentimes as a measurement, so I know just how big it is. The other thing that I use is my thumb, or I should say my thumbnail. I know that when I'm terminating, for example, cat connectors, that if I make the cables from the base of my thumbnail to the tip of my thumb, that's the right to slide it into an RJ45. So again, using the build procedure like that, it is kind of interesting to really kind of put a number to things that you sort of intrinsically know. But if you're building things for repeatability, or somebody that's not yourself building them, obviously that has to be all spelled out, mostly just for QC. And then once obviously that person gets the hang of it, you don't need to measure it, but it is interesting quantifying those numbers. So once you have this down, we trim these. Again, if you notice, I'm using my thumb tip here and not measuring. I think, what did I say? It should be about 1 inch, and then once you strip it, you should have exposed copper of about 3/8 of an inch, and that will allow you to stick a ferrule on there. Did you hear me, electricians? We use ferrules here at LM. That's always the comment on every video, especially my older ones when I was still figuring this stuff out. They're like, you should be using a ferrule. It's going to light on fire. So we do. We use ferrules even for stuff like this. So we are using the catapult stripper. If you've noticed, if we've cut this correctly, the back sort of thumb portion of the connector, or of the tool, is right against this outer jacketing, and then we're using the 12, the top 12 on this. That delineates what weight gauge of conductor you're stripping. So the top is 12, and then you should be left with about 3/8 of an inch of cable. And what I like to do, or conductor, or of wire, let's say wire. What I like to do is just spin that, and then I will use the 14 to 16 gauge ferrule. I know it's 12 gauge wire, but I do want a very tight crimp on this, and I spin that down until there's a nice amount of tension. We will take our completely expensive, overpriced $150 crimp set and crimp that down. You know why? Because it says Knipex on it. And we will repeat that for the other conductors. We started with ground like the good electricians that we are, even though I'm not an electrician. I'm a daywalker electrician, as the comment section will tell you. And we'll go around and just spin these guys on like this. So sometimes, like if you notice, these ended up being correct. But in terms of cable length, but if you notice, if we go look at this one, see how the wire just sticks out just a scoosh? Well, you can move this before you crimp it so that it's not sticking out the top, and then you can crimp it so that it's okay. Now, the next step that we like to do here is take a lineman's tool, which is a desert island tool for me. This is one of my all-time favorite, most useful tools. They are a hammer, they are pliers, they're cutters, they're crimpers, they're this little puller thing on the end. I love these things. So what I like to do is take these, and we'll take the teeth portion, the plier portion of this, and we will just squeeze this down. So I like to give it a good squeeze, and then I sort of like to just work my way to the tip to make these ferrules flat. So good squeeze, and just work your way to the edge. So the next step is I build the female portion of this connector first. So one of the reasons why I like these Lexlock plugs is there's no screw to get access to this. So you can open these little doors like this, which are quite lovely to work with. So I always like to start with the ground, you know, obviously following good electrical protocol, ground, neutral, hot. But then also, for whatever reason, on certain of these female ones, the ground is sort of hard to get in. So I find that if you start with that one, you have more leverage. And then just give it a little tug to make sure that it's secure, which it is. And then I have in my build procedure that if you need a little help sticking it in there, then needle nose pliers are good. So if you do find yourself doing that, oops, see, like that one wanted to pop out. That's why we check those things. See, look, this worked out well as an example. You can take your needle nose pliers and don't grab the conductor itself. Grab the blue portion of the ferrule. So what I like to do is squeeze hard and then stick my thumb on that to get some leverage, and then you can close the door. And there you go. That's nice and strong. So when you close these up, this portion right here has this little tab that goes right here. All you do is match the line on the back portion to the tab, and it will go right in. We will use our Phillips screwdriver to tighten this down. Okay, and then the little style points that I like to do here is they have these cord grips on the back. There's one that's essentially the nut, and this one I guess would be a washer for all intents and purposes. So I like the nut portion to be parallel with the ground pin, so that in a commercial application, when you plug the cord in like this with the ground pin, you don't see the screws. Is that important? No, but I just think it's a subtle difference to you know, make this go. So the way that I like to do this is I like to not tighten one side at a time. So my instructions say quarter increments. You don't really need to do that, but you know, for all intents and purposes, it's like I think about it like changing a drum head so that you have even tension. Again, is that super important? Can you probably do one side? Yes, but these are just build practices to do. And the other thing is, I feel like if you're reading the instruction manual to build one of these, you don't have a lot of cable experience. So, you know, writing it in the most simplified way so that you can incorporate good build practices in is a good thing to do. So if you've noticed, we have our heat shrink. I did not terminate this, and the reason why is I don't terminate it until the cable passes inspection. And that way, if I get interrupted or anything like that, I know that this cable hasn't been QC'd yet. So we'll flip it over, and now we will do the male portion, which is the exact same build procedure, and I'm just going to do this without talking so that you guys don't have to listen to that. So we'll put our heat shrink on first. then the back portion of the connector, and then we'll strip. So we use the side cutters here instead of the flush cutters just to save the blade. Not that anything's really expensive, but you know, I think these are 6 years old at this point, and we're still using them. I mean, they're, you know, $9 for those things, but I try to limit what I use with the flush cutters just to make sure that that blade is always sharp. Oh, I forgot to mention when we did this. So basically what you want to do is these have an auto lock on them. So you just squeeze to release. And then what I like to do is just close it just a little bit and put it on the connector and then push with my right hand against my left to make sure that it's seated. Again, just give this a little spin. Like this one's a little long, so we can just leave it right there. Okay. And that proves that if even simple tasks, when done on camera, can be tricky. Because I'm trying very hard not to have my head block the shot, which I'm sure it probably has done already. Okay, so this is good. What I'm going to do now is just plug this in, and then we'll use our cable tester to make sure that we are good. Hey, what do you know? So the cable tester gives you a green light, and it also says correct, which I enjoy. So now that that's done, that this passes inspection, we will shrink this down. So I like to shrink this down with the ground pin up. So the corresponding box that this is designed to plug into has the ground pin up. So when you look at the cable, it says LM because ABB, always be branding, baby. Well, that's ABBBBBBB. Okay, so now that that is done, I like to flip the cable over, and we will add our branded LM Taurus Systems Velcro tie, which is locking. So all you do is wrap that around the cable like that, insert that, pull, and now it's locked. So the way that I like to do this is I will center it, kind of get the cable so that it's relatively tight and compact on the table, and then we'll wrap this around like this. And then that is built, and then to make it retail ready, we will add some zip ties. So the name of the game with this is, these kind of go in confidence monitors and all kinds of variety of cases, so they will oftentimes get thrown in a drawer. So I just don't want them flapping around. So we'll make that tight, securing this conductor like that. Move our heat shrink here to the middle, just like that. And then we will put this guy like that. Make that nice and tight. And then we'll take our flush cutters, which this is your swag moment of making it nice and flat against that. And then double check that with your thumb so there aren't any sharp edges. And there you go. The relatively retail ready LM Taurus Systems 25-foot power cable. So I have this on our web store as a standalone part for the 25-foot. There's also a modifier on the web store that will allow you to configure this up to 100 feet. The rolls that they come in are 250-foot rolls. So if you want one up to 250 feet long, I can build you that. You know, and again, the other thing that we do is we do sell this cable in bulk, cut to order. So if you want me to hack you a piece off of the if you want me to hack you a piece off of the reel, that's no problem. If you don't want to buy a 250-foot reel or you want to do it for another project, just LM Cases online for that. You know, we have the connectors on there also if you want to build your own. But yeah, this is our standard cable. I mean, again, I did this for all the cable buildings or all the cable builds that I've ever done. I never really thought it necessary to build a standard male to female Edison extension cord. But since we have so many of these coming up, I just thought that I would make a build procedure strictly for our shop friend that's coming in to help Ben and I. But, you know, again, if you guys are looking for a high quality extension cord, buy it from us. You can, chances are you get it built by one of your LM brothers. And again, if you want to buy it, the link to the web store is below. If you have any questions, please just leave a comment. In the comment section below. I'm sure you guys will. Again, when I came to make a build procedure video, I thought to myself, why not put it on YouTube? So anyway, thank you as always for watching. I'll catch you guys on the next one. Bye.